All right, today we're digging into something pretty cool. The place where one of our oldest industries, agriculture, meets some of the newest technology. We're going to see how a new generation is literally using lines of code to plant seeds for the future.
I know, it sounds a little out there, right? But that's the big question we're tackling. We're going to explore how a piece of software, one actually built as a student project, is trying to solve some of the biggest challenges in farming today.
But before we dive into the solution, we really need to get a handle on the problem. So let's take a quick look at the high-stakes world that modern farmers are dealing with every single day.
Just look at this list. It's a lot. Farmers are under this immense pressure, It's a constant juggling act against things they can't control. Crazy weather, diseases that pop up out of nowhere, and the super complex science of what's happening in the soil. And every single one of these things directly threatens the main goal, getting the biggest harvest possible.
Okay, so with all those challenges on the table, how can technology possibly step in to help? Well, as it turns out, sometimes the most game-changing ideas are born in a classroom.
And here we have it. This is what we're focusing on today, a smart agricultural prediction system. And what's so cool about this is that it's not from some giant tech company. It's presented as a final year project for computer science students, which just shows you how powerful and accessible this kind of tech has become.
And this right here is the engine under the hood. It's this awesome mix of tools. You've got Python as the brains of the operation, scikit-learn bringing the machine learning magic, and then all the standard web stuff to make it look good and easy to use. It's really the complete package for building a modern, data-driven app.
So we've seen the challenges, we've seen the tools, but how does this thing actually work? Let's pop the hood and take a look at the core features of this digital farming helper. At its core, the logic is actually super simple and elegant. First, it just drinks up data. We're talking weather history, soil info, past crop yields, all of it. Then, the machine learning models get to work, finding all these tiny patterns that a person would probably miss. And finally, step 3, it spits out clear, simple advice a farmer can actually use. So let's check out its first big trick, predicting the harvest. It uses a model called a random forest regressor. Now, the best way to think about this is to imagine you have a whole room full of expert farmers. You ask each one for their opinion, and then you combine all their wisdom to get one super accurate forecast. That's kind of what this model does with data. Next up is disease prevention. And this is a real game changer. This is about shifting from being reactive to being proactive. Instead of waiting to see sick plants and then scrambling to fix it, this system analyzes all the conditions to flag the risk of disease before it even starts. That could literally save an entire harvest. This feature is all about precision. So instead of a one-size-fits-all approach to fertilizer, the system looks at the specific crop you're growing and gives you a custom recommendation for the NPK mix. That's nitrogen, phosphorus, and potassium. It's about giving the plants exactly what they need, no more, no less. And, of course, you have to tackle the biggest wild card of them all, the weather. This uses a model that's basically a fancy way of saying it looks at all the past weather data, finds the trend, and makes a really educated guess about what's coming next, specifically for rainfall. It's not a crystal ball, for sure, but it gives the farmer a huge statistical advantage when they're planning ahead. Okay, so this is obviously a super clever student project. But let's be real, why does it actually matter in the grand scheme of things? Let's look at the impact this kind of thing can have beyond just getting a good grade. And this table just lays it all out so perfectly. The ripple effect is huge. For farmers, it's a tool for smarter decisions. For scientists, it's a new way to study crops. For other students, it's an amazing learning example. It could even help governments make better policies, or be the starting point for a brand new company. It's just one idea with so many potential uses. And you don't just have to take my word for it. This quote from our source material really just nails it. The point is, this isn't just theory. This is a project that shows real-world skills that are desperately needed in the industry right now. It's the perfect bridge between learning something and actually doing something with it. Now, for full transparency, the source for all this info is actually a product page. This whole system, it's being sold as a complete project kit for other students. So let's break down what's actually on offer. First things first, the price. It's listed at 499 Indian rupees. I mean, that is incredibly accessible. It just hammers home this idea that you don't need a massive corporate budget to get your hands on this kind of advanced technology anymore. And for that price, you're getting the whole shebang. It's a project in a box. Everything a student needs to get this running, understand it, and present it. You get the code, the data, the ready-to-go models, and even templates for their final report and presentation. It's literally built for them to succeed.
The offer is also broken into tiers, so the base package gets you all the files you need to do it yourself. But if you need a little more help, there are paid add-ons. They can set it up for you, give you a one-on-one explanation of the code, or even make custom changes. It's a smart model, a really low barrier to get started with options for more support if you need it.
So let's just pull back for a second. What does a project like this really mean for the future? Because it's not really just about this one system. It's about what it signals for technology and for farming itself. And this is the big takeaway right here. The tools that you need to build these incredibly smart systems, things like machine learning and data analysis, they're not locked away in some high-tech lab anymore. They're out there in the hands of students and creators and anyone with a good idea. Which kind of leaves us with this final, pretty wild thought. When you take this incredible new access to technology and you mix it with the creativity of a whole new generation, you just have to ask yourself, could the next big leap forward in how we feed the entire planet already be growing not in a field, but on a student's laptop? Definitely something to chew on.